We had a discussion today on exactly what to talk about tonight. And both Sean and Amanda had asked me to do various things. One of them to do with putting on connectors, RG213 connectors, something to do with transmission lines. And I thought I might just start with sort of a basic rundown on transmission lines, because I think that everybody tends to make it too complex. And I used to find when I was teaching engineering students that the approach that universities take is they start out with the mathematics, and the poor guy sits there not knowing what the hell he's going to use it for. So you need to have a feeling, you need to have some sort of a gut feeling for what a transmission line is doing. Well, we all know that we're putting a signal in one end and taking it out of the other, right? There's a hell of a lot of other things going on in there. And so, first of all, if you've researched it at all, if you've looked it up, you'll find that it's pages of mathematics. And if you really want to quantify what's going on in a transmission line, yeah, you've got to use a lot of math. But do you really need that? That's the question. Where are we sitting here? Most of us are looking at the sharp end of the stick. You're not in a design lab. Okay? You want to be able to, if I'm correct, you want to be able to connect an antenna to a radio correctly, make it work. Is that simple enough? Okay. So the things you should remember to make this really simple is that with transmission lines, you only have 3 possible situations. That's it. It's that simple. You have open, you have shorted, and you have matched. Everything else falls in between. Okay? And can be a bit of everything. Okay? What we're shooting for is matched. So that means that the output impedance of the transmitter should be matched to the antenna, to the transmission line. So you want, if the output, most of them are 50 ohms, you want the impedance of the transmission line to be 50 ohms, impedance of the antenna to be 50 ohms. Okay? Game over. How do we prove that? Standing wave bridge. And my suggestion to Sean when we talked about this several months ago, a year ago, 10 years ago, when was it, Sean? was to suggest that you needed 2 basic devices. One, you needed a dummy load, which is a perfect antenna. Okay? Because if you're going to make any tests on a transmission line, you want to make certain that it does have a perfect load on the other end. Okay? That's a perfect load. Because it's non-inductive, it's totally resistive. Does everybody understand the difference between impedance and resistance? Okay. Well, with impedance, impedance is a complex resistance that is affected by frequency. Okay, so this is a pure resistance. There's no reactance in this. There's no capacitance. There's no inductance in this. It's pure resistance. So it is then 50 ohms, pure resistance. So that means that it is a perfect match. This one goes from, I think, 1 meg up to 3 gigahertz. And you can see it's got fins on it, so it will take full power, full 250 watts, without damaging itself. One of the things to be careful with if you're using a dummy load is to make certain that it's got what its operational characteristics are. Some of them are designed for 1 minute on, 2 minutes off, 3 minutes off, that sort of thing. So some of them have a duty cycle, so be careful with that. And if you exceed the duty cycle, then it is ungood. That's a technical term you can write down. Ungood. It will damage the unit, and that's what you don't need. Okay? So after that, you can't use it again because it will not be 50 ohms if you've burned it up. So that's something to keep in mind. They're fairly delicate. You don't want to drop them. You want to, mine is in a padded case. And the idea with that is that it never gets out of that case unless I'm going to use it. They're worth, this one's about $300 or $400. You can get them cheaper, but they will have a duty cycle. You can get them for around $90, $100. But if you're going to have a decent radio operation in any frequency, you need a dummy load. And you also need standing wave bridge, which you know what these are, right?
No, just one question though. You're talking about that will take 250 watts.
This one here?
If you're just testing, you need to use something.
No, but I use it for high power, so I'm dealing with higher power. So you don't need anything this big, but it's the only one I got in the shop, so. Now, I think Sean's got some. Don't you have some dummy loads, Sean?
2019.
Sorry?
In 2019.
Oh, in 20.
No name calling.
I thought that was what you paid for it.
Sorry, Mark. Just going to backtrack 2 other questions. Can I put on a coffee?
Drink coffee.
Oh, is your okay? Okay.
Sure.
You promised me strong drink.
Yeah, okay. I'll put some Baileys in yours.
No, that's fine.
And for those of us, just want to do a brief introduction, because some of these weren't at your April session, and I think we should justify why the hell we should be listening to you in the first place.
I can't give you a good reason.
The pay, you know.
We're here for
There's others that will tell you you shouldn't pay any attention.
But yeah, so why don't we just start with Paul, and we'll just go around, introduce ourselves, and then Martin can just tell us that he reinforce the knowledge that he actually knows what he's talking about.
Okay.
Any questions on the transmission line stuff? I was laying on you there before I was so rudely interrupted by Sean.
No.
So you got a what's that called, a fin cooled dummy.
Load, yeah.
I've also like the mineral bath as well. Is that another?
Yeah, they used to.
Paint can, I see.
Yeah, there was in fact, I think Heathkit had one of those, but the stuff they were using in it is PCB. And there's no way you can.
Transformers.
Yeah, it was the stuff that Hydro was putting into transformers, which was not good.
Okay.
And it's a carcinogenic item anyway, so it's been banned. Most of the dummy loads you'll see now are probably a carbon resistance, because the main thing you've got to do is to make certain that it's non-reactive. In other words, there's no capacitance, no inductance. Because if that happens, then at some point you're going to have a serious issue with certain frequencies. So the requirement is that they have to be pure, perfect resistance, or you can't use them for testing. So my suggestion to people when they're making up cables, and it's something I do in the shop, and we were going to try and do it tonight here to give you an idea of how to do it. What we were going to do was to set up a cable and dummy load, the power meter, and show you how we would do it very simply. And again, you're not going to have massive amounts of test equipment if you're out in the field. When everything hits the fan and you're running around trying to keep things working and stuff and getting on the air, if you need to make up a cable, you're not going to have the benefit of a lab to check those cables out. And always check a cable before you use it, because if you don't, you can very easily have an error in putting together your connector on one end or the other, and you're in trouble. So you can be chasing yourself around trying to find a problem that you've created yourself. And I can tell you from experience that I have a lot of clients that are offshore sailors, and I think 90% of the problems that they call about with a radio system on the boat. And you've got to think about your radio as a system. It's the radio, the coax connectors, the tuner, the antenna. That's a system. Okay, so if you've got a problem with that system, you have to know how to break it down and check each part of the system to know which is causing the problem. Now, with new radios, new HF radios particularly, they have a circuit that's built into them that's part of the design, because one of the things that solid state components do not like is this high standing wave ratio. Now, do we know how that turns out? Do we know what happens when you get a standing wave ratio?
Why you're getting it?
Yeah, what happens? What is really going on? Again, let's go right down to the simplicity.
The output power is coming back into the.
Exactly.
Inbound, so
So if you think about it, what are the two worst situations?
short or open.
Short or open, okay? And so what happens in a case like that? What happens to the power that's transmitted from the transmitter?
Stays in the transmitter.
Being reflected back into.
No, it's sent out along the line and it comes back.
To
The
the
greater the mismatch in impedance, the greater the percentage of power is reflected back. What's the difference between an open and a short?
0 and 100?
No.
No?
It's just at a different phase. It's just a phase shift,
Oh,
okay? So, is that simple enough? Yeah, straightforward. So that's what happens. And so, solid state devices, when they see that energy come back, and what happens when you get a high standing wave ratio, you can have voltages soaring to thousands of volts. And then you can get arcing, you can get all sorts of problems with that, because you haven't got a match. And those signals are flying back and forth on the cable, and the voltages build up. And you can suffer from, oh, is this the one with the Bailey's on?
I could draw some.
No.
so maybe I don't understand the difference between the open and short.
No, there is no
There's
difference.
no difference.
Just think of it from the standpoint that all of the energy you transmit out is going to come back.
Okay, so they
But it will be in a different phase. It'll be 180 degrees difference if it's open for a short, one way or the other. There'll be a 180 degree phase shift difference. Doesn't make any difference to you.
okay.
The result is the same,
Yeah,
okay?
they're both gonna cook your
They're both,
transceiver.
both situations are ungood. Yeah. So what happens in a situation like that is the voltage tends to soar in the transmitter, and it will take the finals out just like that. Now, vacuum tubes, one of the big advantages of vacuum tubes is they can handle a lot of a bad standing wave ratio. But solid state devices can't. So what happens is the manufacturer says, I know all these idiots that are going to use this thing are stupid, so we're going to build in a circuit that is the minute it senses a high standing wave ratio, it shuts down the transmitter. And the transmitter power will be reduced in percentage to the amount of standing wave that are coming back. Increasing the amount of reflected power will affect the power out of the transmitter. So if you've got a minor, in case you've got a minor problem with mismatch, okay, you have a small amount of mismatch either in the antenna or the line, and what you'll notice is, what's going on here? I'm not putting out my full power. What's causing that? So that's when you need to put a dummy load on the cable. And I was giving you an example before of people that call me and they say, my radio's dead. Oh. Is the receiver still working? I can hear on it fine. So it's not dead then. No, but the transmitter isn't transmitting. So how do you know that? Because on the screen, it's got a little idiot light that shows you whether you're transmitting or not. And he said, it's not transmitting. So I said, well, what I found 90% of the problems there is not the transmitter. It's the coax transmission line between the transmitter and the tuner. Because they've gone into some shipyard, to get the boat hauled, and the guy in the thing, I can fix cables. And so That's 90%. I can easily tell you 90% of all the complaints I get is from that coaxial cable. So, if you want to know how important it is, that's it. So, if you have to troubleshoot something like that, how do you do it? Really straightforward. Disconnect, first of all, take the radio, the transmitter, the transceiver, disconnect the output, and get a short cable and connect your dummy load to the transceiver. Check it. Full power? Ah, nothing wrong with the transmitter, right? Go to the other end of that cable, connect it back up to the transmitter, go to the other end of the cable, if it's going to a tuner, for instance, take it off the tuner, connect it to the dummy load, fire it up. Oh, full power, not the cable. All right? Then you've at least nailed it down to, you've done your troubleshooting, you've nailed it down to the item that's causing the problem. And it's that simple. It's not a complex situation.
Did I understand you to say just then that you test the cable from either end?
No, you can,
Is that what you were saying?
I would connect the cable back up to the transmitter. Okay, remember we've disconnected it. Now I'd connect it back to the transmitter, and at the other end of that cable, put the dummy load. Okay, so you've got a perfect load there. Now, if you fire up the transmitter, and you still don't have full power going out, then the trouble is in the cable. Okay, now if you put a standing wave bridge on there, like this one I was showing you, it'll tell you how much reflected power you've got coming back. And so this is really good if it's not enough to really screw things up. But, hey, we're not putting out full power here, but we are putting out power. This will tell you. And so at that point then, again, pull the same thing, do the same thing, only put the meter in. In other words, take the cable off the transmitter, through the back of the standing wave bridge, out the other side to your dummy load, okay? Fire it up, full power. Oh, yeah, full power, that's reading it, there's full power. And don't go by the idiot lights and stuff on the transceiver because they won't be calibrated. Use a good standing wave bridge and it'll say if it's a 100-watt transmitter, by God, it's 100 watts. And so you know then that everything's working as it should, okay? So the troubleshooting is really not difficult. It just requires a little bit of, oh, hey, what's going on here? You know, what could be causing this? And so you've got to find out. So don't think of an antenna, transmission line, tuner, and antenna as separate items. It's a system. And you're going to use it as a system, but you're going to have to separate that, break that system up if you're going to test. If you're going to do any testing, find out what's wrong. Any questions on that? So it's quite straightforward. And once you've done it once, that's all it'll take, believe me, once you've gone through the process. And so my suggestion to you is that you play with this a little bit. Once you're doing your setups with your transmitter, if you're building a cable, what we're going to do tonight, as I said to Amanda and Sean, let's just use a transmitter, okay? Let's fire it up. Let's use it as a signal source. And what I do in the shop when I'm making up cables, I will make up the cable, whatever length it is, put my connectors on, and then I will connect it up to one of the transmitters, and the other end to the dummy load, and I will fire up the transmitter on all of the frequencies in the HF range, and watch the standing wave bridge. So in other words, I want to know, is that cable flat? When I say flat, I mean, is it matched all the way through the frequency range? If it is, hey, it's good, bang, move out.
Range being from,
Well, in my case, it would be an amateur radio HF transceiver, which is 3 to 30 megs.
okay, so the whole.
Yeah,
spectrum,
I
whole
just
spectrum.
grab some frequencies in there, fire it up, and you've got to switch the radio to FSK or whatever. A lot of complaints I've had from clients when I've talked about this. They call me and say, "Well, I couldn't tell." I said, "What do you mean you couldn't tell?" Well, when I speak into the mic, the signal's going up all over the place and the meter's going over the, I said, no, 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 no. You can't use audio on single sideband to test for output of the transmitter. Because what do we know about single sideband, people?
No carrier.
What's the output power? What controls the output power? Yeah. The output power on a single sideband transceiver is directly proportional to the input audio voltage. It's a voltage device. It's a voltage device that converts to power. So if you're setting up a Pactor modem, for instance, one of the things that a lot of people don't understand is that there's an issue here because the modem is essentially putting an audio signal into the transmitter, okay? So what do we not want to do here? In a commercial transceiver or the amateur ones, do you know any other circuits that they might have in there to stop you from playing silly bugger? Any ideas what they might be?
Like a diode, you mean?
No, they limit the amount of
Modulation.
audio drive, the modulation you can put into the transmitter. Okay, that's built in, okay? So you cannot overdrive the transmitter using your microphone. However, if you connect your Pactor modem up there, you can drive the transmitter into saturation, and that can blow the finals. Not a good situation. So there's a process that you need to go through in order to set the power output for digital that you don't have to worry about when you're using audio.
That's a setting on the modem.
You can actually control the output of the modem from the computer. And there's a process that you have to go through in order to set that up so that the amount of output power from the output level, shall we say, from the modem produces the right amount of output power from the transmitter.
This is the FSK, PSK stuff.
FSK, PSK, yeah, and I don't want to get into the depth of that tonight because that's a whole digital
No, but
issue.
just so that people know that when we go through the software at some point again, you'll see it.
Yeah.
Bernie, what was the acronym they used during the coast to coast exercise that we weren't too sure what it was?
Yeah, that's a good point.
Yeah,
What was it?
I don't remember. I'd have to go down my notes.
Yeah.
It may have everything or nothing to do with this, sorry.
No, it could have something to do with it.
FSR?
Was it FSR?
Might be.
Yeah, I think it was FSR. They said
FSR.
FSR. They said FSR during the exercise, coast to coast.
Or service road?
That's what I always thought. too.
Yeah, I was going to say,
That's
what
what
was
I
the
thought too,
what was the context?
Yeah,
I
that's what-
don't remember.
Yeah. Okay.
So, but yeah, it's popcorn. Anyway,
Yeah,
sorry.
it'll come back.
No, I hadn't heard that, but and I'm not involved in much of the.
No, I completely off topic. My bad.
Anyway, so the importance of making sure that you have these adjustments so you don't blow your transceiver.
Yeah.
Yeah. And I think that's a topic that I have a write-up on it, and I'm happy to. I've got a little overhead and PowerPoint that I'd be happy to give you guys when you get to that stage and play with it. But it's a fact that the Pactor modem has, for those of you who are digitally inclined, the Pactor modem uses FSK and the PSK mixed. And it mixes, and that protocol that they're using is really interesting. It will run anywhere from Pactor 1 right up to Pactor 4, depending on what's required. And I mean, if you think about, if you've looked at propagation, and you know how weird the propagation can be at times. Have you ever been on HF? Most of you listen to HF. Do you know how complex propagation is?
Mm-hmm.
Yeah. That protocol that they wrote takes all of that into consideration in real time, which makes it. That's taking the IT area and moving it up to PhD level, believe me. So, Did I cover the testing the system and talking about the cable?
Yep.
Are we happy with looking at matching transmission line, basic transmission line theory? You don't need anything more than that, believe me, you don't. If you can grasp exactly what I've told you, you will not have any more trouble dealing with transmission lines. It's that simple.
When you're, another question, when you are testing, are you also making a point of just testing at a lower power setting anyways?
No, I use full power.
Full power?
Yeah. Well, for instance, if I'm putting if the cable's going out for an HF transceiver that is 100 watts, I'll test it at 100 watts.
No initial, say 5 or 10 watts and then going to 100?
You can do that.
Just say, okay, from a safety point of view, instead of cooking at it, you got a little bit
Well,
more latitude
remember
with
though,
5 watts.
Remember though with the transceiver that if you have damaged, if you have not done a good job on the cable, the radio will say, I can't do that. It won't put any power out. Yeah. Yeah. And it's good to know that because a lot of people scratch their head and stare at the wall when they say, well, the transmitter must be damaged because it's not putting out any power. Well, maybe, okay? Don't jump to that conclusion until you've tested it. And it's really difficult if you don't have the test equipment. That's the whole key to this. You don't have a dummy load and a power meter, you are SOL if it comes to trying to fix anything. You really are. And when you look at the amount of money, I get people going offshore, and I tell them, I say, hey, I'm not going to be out there. You got to live with this system, understand something about it, and spend a couple of $100, buy some decent test equipment, and learn to use it. All right? Because you can't call me up, I'm not coming. Okay?
Can't afford it.
And, yeah, and so the thing is that these people will spend thousands and thousands of dollars on sailing gear, and they will go nuts if you tell them they need $200 worth of radio test equipment. Very poor economics.
Pay me now or pay me later?
Yeah, yeah. Yeah, I'm happy they want to fly me out there, that's fine, I'll fix the thing for them. But, so that is transmission lines. That make sense? Have I covered it? Amanda?
Yeah. I think what we really need though is to actually see it. We need to see the process.
You want me to blow something up?
Absolutely.
Before you do, Martin, sorry.
Sorry.
What is the basic toolkit for troubleshooting? So you said you got a power meter and a dummy load, and that's it?
That's it.
That's it? Okay, maybe a small.
Well,
patch
I would
cord.
use a DVM as well, you know, I mean, and to get a good one, I use one I've had for years and years. It's,
Multimeter.
that's the other unit that I suggest people get.
Martin, do you mind to actually spell out your abbreviations? A DVM is a?
Digital multimeter. And I use a Fluke because I always figured that if you're going to call your company Fluke, you better have a good product.
It wasn't.
And they are a little more expensive, but I've had this one for down near 15 years. And it looks like a dam. Yeah. So that's maybe the other piece of test equipment that you want to think about is a good digital multimeter. Yeah. And really, from a start, that's all I would. That'll get you, if you have something like that available, to you when everything hits the fan, you can solve pretty well any problem. Because it's a matter of isolation. Once you get to and it doesn't take you long, maybe take you 10 minutes to find out what's causing the trouble in that system. And then from then it's just a matter of, we got something to put in place, or can we build something, can we, now it gets a little more complex, but you've at least isolated the problem. But 99% of the time, it'll be cable, it'll be a coaxial cable. So no questions on that? What else did you want,
Yeah.
Amanda?
I think in terms of the theory,
We were
that's
gonna-
good.
Yeah, I was mentioning we were gonna take a radio, set it up.
Yeah.
And we can do that too.
Well, I think that's what we need to do. Who here would like to actually see the process happen?
Let's blow up one of the
Perfect.
SRD's radios.
Excellent.
That's what you tell my students.
Tune for maximum smoke, yeah.
Tell my students, let's tune for maximum smoke.
TMS.
Yeah. So you guys wanna set your stuff up and?